We talked about triangles, quadrilaterals, um, pentagons, hexagons, octagons, any straight sides that close, they're polygons. Congruent polygons have the same angle measure, same length. We just said two that look exactly like, same side length, same angle measures are congruent. But similar polygons have the same angle measure but different side lengths. That makes their side lengths in proportion but different sizes. So here we are. If we move this triangle, you can see that it's different size, but if it's equal distance all the way around, you can tell it's proportional. Another way to tell is if you slide that angle right in and it's a perfect match on any of the vertices, you can see that it is a perfect match. The angles are equal. That was a main idea from yesterday, that the angles are congruent on a similar figure. Okay, so understand that two similar figures have congruent angles, but the sides are proportional, not congruent. All right. So these are similar. They have the same shape. Their angles are equal. We just proved that. But their sides are in proportion. So angle A matches with angle what? Over here. Angle A matches with angle, can you see? X. Very good. Thank you. Oops. Let me get that. Angle X. Angle B matches with angle Y. Very good. And angle C matches with angle Z. Z. Awesome. And we would read it as angle A corresponds to angle X, angle B corresponds to angle Y, and angle C corresponds to angle Z. Looking at the side lengths, we would say segment AB or side length AB here matches or corresponds to XY. So you would read this, segment AB corresponds to segment XY. And you put a little segment on top to let everybody know you're talking about a line segment or a side length. Okay, BC corresponds to what? YZ. YZ, very good, YZ. And then AC corresponds to XZ, yes. Could you say ZX? Well, you'd want to then go CA. You want to go in the same direction, okay? But make sure you use the big word like corresponds to. All right, very good, guys. You did great. Okay, let's look at what the world. The next one here. When will we use this? The real world application. You use these for scale drawings. Maps. Have you ever seen the scale on a map? You know, a map, you couldn't really carry the whole world in your pocket as you're traveling. You go to the beach. If you've ever been to the beach, I love to go to the beach. It takes me about 4 hours to get there. I always need a map to get there. And used to, before the age of technology and cell phones, we had to actually have a paper map in our glove compartment, and you had to map it out. You have these little, what we call scale factors. So for every centimeter on the map, may indicate that might be 10 miles or 20 miles in real life. That's a scale factor, and it's drawn to scale, what we call drawn to scale, just like these that you see here, these examples with the cricket. Is that a cricket? Is that what that is? Yeah. Okay, and then just check it. And then this is like an example of an enlargement. It's an exact replica but enlarged, and then an exact replica that is like scaled down or scaled up. So this is scaled down, a reduction. Why is that important? Well, if you've seen architects, for example, they have to create these scale drawings for buildings that they're going to build, and then they might actually create a structure drawn to scale to let whoever investors that are going to give them some money to build this property, they want them to see what it's going to actually look like. But they can't build it. They can build a replica, and you want it to look like the final product. So there's a lot of real-world application for drawing things to scale and similar figures. So the main idea for yesterday, corresponding angles and similar figures are congruent, while corresponding sides are in proportion. So you want to remember, if I look at this one, if angle A here, if angle A is 25 degrees, then what is angle D? 25 degrees. Very good. That's the main idea from today and yesterday. They are equal. Angles and similar figures are equal. So if I look here, and I think I deleted it by accident, but if the value of angle E here, I want to know the value of angle E, and I say that this is 45 degrees, then I can tell you what angle E is. What is angle E then?
45.
45. Very good. And then here, the value of N. What would the value of N be?
120.
120, because the corresponding angle is 120. And then, of course, this one, what would be the value of C, looking at the similar figure? What would it?
40.
40. Awesome. So our last thing would be this symbol here. I don't know how clear it is to you guys, but this symbol here, this squiggly line, is similar to. When you see that, it's similar to. So an example would be here where you have triangle ABC is similar to triangle XYZ. So this one, for example, we would say quadrilateral ABCD is similar to quadrilateral EFG and H. So when you're comparing, or you're wanting your reader to know that two shapes are similar, you would use that symbol. And this is your class kick assignment for yesterday and all the vocabulary we just used. So if you refer back to what we just talked about, you can fill all of this out. And then using your highlighters. And I went in and made some corrections for some of you that's already done this. If you haven't, you need to get in there and do it so I can make corrections before Monday, and you can improve your grade. Here's the similarity statement. Here's another similarity statement. We're going to talk more about that tomorrow, okay? A little bit today, all right? So any questions about any of that before we get started for today? Awesome. All right.